You know, sometimes it seems like things happen in waves. So I've got, this is a EZ3X head out of an SVX, and we're going to be installing guides. So customer brought in some OEM Subaru guides. Notice how little they are. They're pretty small little guys, both intake and exhaust guides. Also purchased exhaust valves from SuperTech, and I believe these are just standard size, so they're not oversized or anything. And I'll be cleaning and refacing the original valves on the intake side. But the job for this today is to remove the old guides, install the new ones, and then we're going to machine the valve seats. Before we do all that, I'd like to, verify what the valve heights are, because this is actually a hydraulic lash adjuster head. So instead of having direct acting mechanical buckets like all the EJ series engines have, this EG here has hydraulic buckets. That means that valve lash is taken care of automatically by the hydraulic adjusting mechanism inside the bucket. So I don't have to hit a specific valve height dead on. I can go within a range. I'm still going to set them all within each other, a few thousandths of an inch height between each one of them. But I don't need to hit a very specific number so that valve lash is close to what it should be with the cams that they're going to be installing, like on the EJ series engines. The FA and the FBs also. So the first thing I need to do is to verify the valve height. Now the way I'm going to do that is by using a depth micrometer and this valve height checking gauge. So this is a pretty simple gauge. It's got a, what do you call it? It's got a dial indicator on here, and on the inside of this, just an aluminum tube, there's a larger stylus or probe tip on the end of the dial indicator. So when I put this from the top of the cylinder head down, the valve will actually, once it's seated inside the cylinder head, it'll go up and it'll push that dial indicator to whatever reading it is. And I could use a pair of calipers, like a dial caliper, to measure whatever that height is. I just recreate it, and whatever comes up on there and comes up on this is the height I want. But I do like to use this method here because the tube here that sits down on the spring seat, it squares up real nicely on the end of the depth micrometer. So first thing I'm going to do is set this, and looking at my notes in the past, I want to say these are around about a 1.220, 1.225. So I need to put in the different depth micrometer rod. We'll stick that in there, and I'm going to dial in the 1.225. There we go. And 1.225. There we go. So I have that set, and I'm going to take my my gauge here and see I'm off by about 20 thousandths of an inch. So I just need to look at it and say I'm going to move it over 20. There's 5, 10, 15, 20. And I just like to get it close to 0. So I'm off by 1. And there we go. So, and this is going to help me verify what the valve height measurement is on the cam side. Now the other thing that's important on these, because these valve guides are exceptionally short. These are probably some of the shortest ones I've ever installed. Let me see if I can get this open. There we go. So these valve guides are teeny tiny little things, and their valve height is their height from the top of the head is very important, because you don't have a lot of leeway below the surface down into the port on these. And so the valve height on these comes out to 8.5 millimeters, which I think is 335 thousandths. And I'll be using the same tool that I use in the other video. It'll be the automatic or kind of the depth stop valve guide installer, and I'll have that set to install these new guides. So the first thing we'll be doing to set up, I'm going to roll it over. and we're going to check the valve height on all the intakes and the one exhaust valve that he brought me. And I'm just going to duplicate those heights after the valve machining, the seat machining, of course the guide replacement, so that all he has to do is put in the buckets, put in the cams, and he'll be set. So we'll get that set up and I'll be back. All right, so we're ready to measure the valve height. I've got all the valves set up over here, just right there in the front of the shot. And I'm just gonna stick in each one of them in order. I'm gonna make sure that it doesn't have any dirt or anything on the bottom of it. Now I haven't ground these or even cleaned them. So the measurements will be more like the vehicle was running, and hopefully everything was good. And what I'm going to do is just mark, because I've got it set to 1.225, I'm just going to mark on the head and then take a picture of it with my phone, so I've always got it, whether or not it's plus 1 thousandths or 2 thousandths or minus 1 or 2 thousandths compared to my 1.225, and that'll be my standard measurement. So our first one here, it looks like we're coming in under 3 thousandths, so we're going to put a -3. We'll put -3 on that one. And then we'll stick in the next one. And we're just going to go down the row and try and get them all in. So this one here is a -1. So -1. And the next one will be third intake valve. We are a -4. Now I do understand that the machining on the spring seat isn't perfect, and to start ahead fresh and new and expect this to work, meaning putting in new guides and new valves and not having any of the original ones, this wouldn't necessarily work, because that valve adjustment is really setting the center line of this cam bearing bore to the tip of the valve, because the cam has got a base circle on the lobe, and its diameter is going to be measured from the distance from the center line to this down to the tip of the valve, and the lash adjuster needs to take up the rest of that space. So there we go, we're on number 3, going on to number 4. Looks like we're only varying by about 3 thousandths so far. Oh, now we're +3. So we'll do +3 on that one. All right, number 5. Now on the exhaust side, I only have the 1, so I'm just going to go down and kind of get a sampling of what it's supposed to be. This one is a minus. Make sure there's nothing in that one. That one was a -7 initially. So that wiped them all out. Maybe a little bit of trash will move it quite a bit. All right, so we're -5 now. So there was about 2 thousandths of trash in between there. So that'll be a -5. And then the last one, we'll stick that in there, and we've got a +5. So we have 2 valves next to each other that are 10 thousandths difference. Now the lash range, or the range on the hydraulic lash adjuster, it might be 20 thousandths or 30 thousandths. Oftentimes they're going to be probably 40 to 60 thousandths. Some of them will be more, some of them will be less. It just depends on the engineers when they designed it. So we're going to stick in the exhaust valve into its guide and measure it up. There we go. So it looks like we have a -3. And because this one isn't the valve that went in each one of these, I'm just going to do a sampling across a couple of them. I don't need to test them all. Looks like there's a +1. Now this is also a good technique, but you'll have to basically assume that everything was okay with valve lash, and this engine came apart for a different reason. So you can kind of see that gauge right there. Put the focus in on that. There we go. You can see it goes around 1, 2, and it comes around, and this one stops on a +1. So +1/1000 of an inch. So we know our standard is 1.225. I'm gonna write that so it's in the picture. And each one of these valves, it looks like we've got a variation of 0.100 of an inch. So if we just set it to 1.225, each one of them, because of the hydraulic lash adjusters in the cylinder head, we should be perfectly fine. Assuming there was no issues before, and the customer hasn't said there were any issues, so we are in the clear on that. So the next thing that I'll be setting up to do is the cylinder head's going to go in the oven, and going to be taking out the valve guides. Now the guides are going to be driven out with a valve guide driver from the port side. We don't want to go backwards, because if you go backwards from the top, I don't know if you can see that in the image here. There we go. So this valve guide has got a lip on it, and that lip right there is what the valve seal is going to engage. If you were to drive this valve guide down this way, that sharp edge right there would surely broach the heck out of the original hole. And I've seen people do it, and you go to put in the new guide, and at the very least, the guide is not shooting in at the right angle. It's actually going in at quite a big angle, and you can see the difference when you go to cut the valve seat, that the valve isn't in line anymore. Because these are not only ground on the OD, but they are bored somewhat precisely on the ID. I guess they are pretty precise on the ID. So ID to OD concentricity should be pretty tight, meaning when you install it, you know, ideally, say if you're a dealership technician and the manufacturer wants you to do it that way, you should be able to install a guide, drop a valve in, maybe hit it with a valve seat cutter, you know, a hand cutter, and you should be good. But not being a perfect world, and the fact that this head has been heated and cooled, I don't know how many thousands of times, things move around, things get displaced in the metal, the grain relaxes, the grain tenses up. So we do still have to cut the seats on these. So once we're set up for removing the valve guides, I'm also going to be removing these exhaust studs. They just get in the way. They, you know, they just get in the way. I don't like the exhaust studs. I like to be able to set the head up on a nice flat surface and be set and ready to go. So once we get set back up for the cylinder head in the oven thing, then we'll be good to go. So I'll drive those out. Now after I drive out the guides, I will be going in and using a soda blaster and at least blasting the chambers and the openings to the ports, so that I'm not working with dirty surfaces. Not to mention, it does look a lot better whenever I get done with my part of the job. And all right, so we'll see you then. So before the cylinder head goes into the oven, I just wanted to point something out. On the end of the cylinder head, there is a tab that's been adhered to the casting of the head. And this is usually installed by the salvage yard that you bought an engine from or cylinder heads from. Or if you've had the cylinder heads rebuilt, they'll install one of these tabs right here on the cylinder head casting. The reason it's here is for them, on their warranty concerns, to see if the cylinder head has been overheated. So the outside of this tab is usually aluminum, or it could be a steel ring. And then on the inside, there's a soft metal that will melt at a specific temperature. Like this one's set up for 250 degrees. So if the cylinder head casting gets up to 250 degrees, the center part of the heat tab will melt out, indicating to them that the cylinder head's been overheated, and whatever warranty was in place is not in place anymore. So if you see one of these on your cylinder head, that's what it's for. It's a heat tab to see if you've overheated your engine. And they can be installed on the cylinder heads, they can be installed on the engine blocks to just do the same thing. So it's all the same purpose. Cylinder heads are out of the oven. They're up to about 220 degrees, so they're ready to have the valve guides driven out. Alright, so that was all the exhaust valves. Now we gotta do, or exhaust valve guides. And now we're doing the intakes. The intakes are the really short ones, so they're not gonna go as long. I know some shops will take cylinder heads up to pretty high temperatures. The problem with that is if you take these heads up to about 300 to 350, the valve seats will actually start to come loose. And when they come loose, if they fall out, you don't notice it. You may not have a chance of putting it back in. Because if it comes out, you can put it back in, make sure it's seated in, make sure there's no trash in the counter bore. So, you know, you have to be careful with that. I know some Dodges, the Dodge Vipers, all the 3.7s, the 4.7s, they all have issues with the valve seats not being in very tight. So you do need to be careful with those because they will fall out even at about 275 degrees. And I don't have a good shot. I'll just take a picture of it, but you can, because this cylinder head was close to an element that was higher than 225 degrees, probably about 260, the heat tab actually melted out. But because he's having repairs done to the head, any warranty that was going to be covered by the source of the engine isn't going to be covered anymore. So I'll go grab the other head. Now after I drive the guides out, I let them normalize on temperature, and then I will then I'll put them in the blaster and soda blast the chambers and the ports. So now the main reason I drive them out after preheating the heads is I don't want the aluminum to gall on the way out. So if we look at this valve guide, I'll get a close-up of it, but this valve guide, which is still hot, has no galling on it, no aluminum transferred to the guide as it was being driven out this way. And the issue with that is if you're galling aluminum on the cast iron, that means you're moving material from the bore of the cylinder head where the valve guide goes. So let's drive these out. Oops, there it goes. Now, since we're focused in on this area, let's take a look at something unique on this head. Now, this is only going to happen on the EG heads, but the buckets on these EG heads, notice there's actually a ring. It's actually a bushing that's pressed into the cylinder head for the bucket to ride on. Now, exactly why they did that, I don't know. Maybe it was just a design choice, because this does kind of look like similar to a wrist pin bushing. So maybe it provides a better bearing surface than the aluminum would be. Maybe they decided because of extra oil consumption on the oil system, not so much being burnt, but how much is flowing through the system, they decided that maybe a better bearing surface than bare aluminum was required. So they do have these pressed in, and they're not normally serviceable, but I'm sure in a pinch, a competent machine shop could actually take care of fixing those. So, part of the process of installing valve guides and machining the seats is going to be servicing the valves themselves. Now, these valves on the back side of the head, the fillet side, they're not too dirty, but on the chamber side, they do have a considerable amount of buildup. Let's see if I can get that into focus there. They do have a considerable amount of buildup, and to remove that, I know many people like to use a wire wheel on a bench grinder, and it can be effective. The problem is how long it takes. And if I've got, in an engine like this, 4 valves per cylinder, 24 valves total, and I really don't want to spend the time doing it, so I try and find a more effective way. So one of the ways that I do is by blasting the valves, and I use a glass bead. I don't use glass grit. I use a glass bead blasting media that will be sure to get down inside all the crevices in between the stamping or the forging, lettering, and the logo. But I get both sides of the valve. I get the combustion chamber side of the valve head. I'm sure to always get the margin, because I want to make sure there's not any cracking from overheating. And then I get the valve face and the fillet side of the head. Now, this one here does have some staining, and that's normal, because it could be from running, it could be from manufacturing. I'm not 100% sure. So here's a quick side-by-side of the two. There you go. And you can see there's a pretty big difference. After this, I machine the face, and of course I have to tip the valve first, because the way that my valve machine runs, it does require that the tip of the valve be perpendicular to the stem. So I will be sure to tip it first, and then I machine the face. I do not blast the stems, even though it is glass bead. Embedding is minimal, but I don't want anything to get stuck in the stem, because it's very difficult to remove, and to remove it I have to remove the diameter of the valve stem. This one here is actually in really good shape. I can tell this car didn't have very many miles on it. The other thing that you'll see is on the tip of the valve, see if I can get in a little bit closer. All right, something that you'll see on the tip of the valve is there's like a discoloration on the end of the valve. And that's actually a process of manufacturing where they induction heat it and then cool it. That's to harden the tip of the valve. And maybe it's because the material that they use is soft, or maybe they just, say, hey, we need more hardness here through the groove, or where the lash adjuster contacts the valve to push the valve open and close. But that bluing on the end of these valves is normal. So yeah, that's what I do with the valves. I'll show you the grinding process, because that's on a different machine of mine. So it'll be a little bit different process, but that's how they're cleaned.